Hello everyone, in this video we're going to instrument our Spring Boot app by using OpenTelemetry Spring Boot Starter. As you know, besides using Otel Java Agent as we did before, we can use Otel Spring Boot Starter to achieve the same kind of result, auto-instrumentation for our service, especially if we work with Spring Boot GraalVM native image. Regarding this case, as far as we know, Otel Java Agent doesn't work, so we can use either Spring Boot Actuator with Micrometer as we implemented in the Spring Boot 3 Observability Series, or Otel Spring Boot Starter as we're going to try in the next seconds. Okay, let's look at our diagram. We are going to build our invoice service that has an Otel Spring Boot Starter dependency. To make it more interesting, invoice service will call order service to get data to fulfill its requests through port 8080 that's already exposed to localhost. That's also the reason why invoice service will be deployed on a different port, let's say 8082. Furthermore, we'll set up our invoice service to send telemetry data to Otel collectors using OTOP gRPC on port 4317. So we need to expose port 4317 on collector as well. Okay, that's it. Let's go ahead and create our invoice service. So start the spring.io. We use Gradle, Java, version is 3.2.2, and cloud. The service is invoice service and jar Java 21. On the dependencies will depend on Graal, native VM, and web for simplicity. So basically, what we're going to have in our build.gradle is the web dependencies, and for GraalVM we only have the plugin GraalVM boot to native. So if we don't have this, so the only difference is the plugin, right? So the web, everything is still the same. Okay, let's check out GraalVM native support, and okay, let's say Lompok. Okay, let's download it, unzip, and open it in your favorite IDE. Okay, I already opened it here. Build Gradle. So web, we have Lompok and GraalVM build to native. Let's get the infrastructure from other service. So here I'll copy the Docker folder and then paste it here. I also want to copy the Docker compose. Okay, by that we have this kind of infrastructures inside the Docker network first. Then we need to first export port 4317 for Otel collector. So now I would like to export 17. And one thing worth mentioning here is that this image is referring to the image of the order service. And to create this image, you can follow the README here. Be aware of the architectures of your environment. So it could be ARM64 or AMD64, for example, because I'm running on my MacBook M1. So that's why in the build Gradle I put the platform is for ARM64, and that's why the image work on my Mac M1. So if you on Linux, you can change the architecture and create your own image. So basically just run Gradle clean build Docker build, and you're going to have the order service. Next thing is we need to rename this one just for YAML. We don't need static, and just delete that. And here's a port So because 8080 is already taken by other service, so this service would be 8082. Now let's add the Spring Boot Starter dependency to our service. Okay, just follow the documentation. We have two ways to import the prompt to our service. So the first way and the second way. The second way is we have to use the depend management block, and with that we have to have the plugin ID here, since we already have this Spring dependency management. So we are going to use the dependency management block here. Dependency management and add OpenTelemetry Starter dependency. So this dependency. Okay, let's run it to see what are going to be configured for us by default. So in order to know that, let's put the breakpoint at the OpenTelemetry auto configuration. So OpenTelemetry auto. Oh, we need to reload. Okay, then let's first for OpenTelemetry auto configuration. Then we're going to put a breakpoint at the OpenTelemetry. So basically, so we would like to know what is the SDK trace provider, SDK meter providers, and logger provider. Okay, let's try to run that. Here, okay, so we have tracer provider built. The endpoint is localhost 4318 traces, and this is actually the route over HTTP OTP protocol. So if we have to explicitly declare YAML, so by default we have tracer provider using HTTP route protocol and metrics. So meter providers for metrics also use the same protocol HTTP, and the endpoint is localhost 4318. The same for log. So we can still using this default, but if we want to use this default value, we have to support the HTTP, the route over HTTP protocol. By that, we have to update our collector, for example. So as you see, currently our collector only supports gRPC protocol. So if we would like to support HTTP, you have to declare it. And the default endpoint of this HTTP protocol is 4318. So we have to export it here as well. 18. Then we can use the default HTTP receiver. So by that we can use the default configuration of our service. But since we want to use the OTP gRPC here, then we don't have to export that. We don't have to support that. Let's back to our file. So now we are going to use the gRPC instead, and by that we are going to send our telemetry data to localhost of 4317. Okay, let's run again here. So now it is localhost 4317, right? And this is the gRPC endpoint. So that's what we expected. Localhost and gRPC endpoint. The same for log. And another thing is we would like to keep the similar to other service. So we'd like to tag the same thing. So in the other service, we tag the service with other service, right? The environment is dev, and the service name here, the service name actually the service dot name equal other service. So basically, we can read the same behavior in our service, invoice service, by applying the same Otel resource attributes. Okay. Otel resource attributes. So we have service names, invoice service invoice service, and environment dev, right? Okay. So let's remove this one. Okay, that's it for configuration. Everything is in place. Let's quickly write some code. Okay, here I'll create a package named ordered, and in here I would like to create a ordered record, and also in this package I'm going to create the order service client. So this class is depend on the REST template, and we build the REST templates from the builder. REST template builder auto configured for us. Then we build the REST template, and then we use it to call our order service as we see here. So our invoice service we will call order service, and to get the order, right? Then we're going to create invoice. So it's invoice. In invoice, let's create a simple invoice record and an invoice controller. So basically in invoice controller, we will call order service, and we will support one API that get the invoice ID. For example, when we get the IDs, we will call to get the order of the same ID of the invoice, and then we will return the invoice with the IDs and the order date and order total amount. Yeah, it's nonsense. But yeah, we just would like to simulate some REST code. And also in this class, we also have the access some handlers. So in some case, for example, we run into some runtime exception, then we can log it. So basically we have a log when it's successfully and log when error happens. So that's the behavior that we want to simulate in this video. Okay. This time, let's spin up our infrastructure and run the service. Okay. Then let's try to send some requests. Localhost. So this time is invoice, right? Invoices 1. Run into error. Oh, sorry. 8082. And then we have invoice 1, invoice 2, and invoice 3. We run into an error because, invoice 3 will call the orders 3, and as you remember, in order we only have 2 order 1 and 2, right? So that's why we got the internal server error. And then let's check our Grafana, localhost 3000, admin, skip. And first let's check our Prometheus. So let's see, do we have a metric? Okay, so Prometheus, we have some data about HTTP server duration millisecond bucket. So what's that? So this is from the order service. So basically the label of order service using Java Agent, and I think the HTTP request duration. So server request duration. actually from the, so this is from our invoice service. We still have the matrix, but the label is different. And how about lock key? Lock. So job here. So order service. So we only see the lock of our order service. So like, so we see we already configured the locks, but it's not for the invoice. How about the trace? So for tempo trace. So trace, we have both ordered and invoice service. Okay, let's see invoice. Okay, so even though we send the request to the order service, we only see a symbol trace here. One trace ID with one span ID. So that's quite simple and not enough. We like to have the context propagation. Okay, let's take a look back at the documentation. So scroll down a little bit, trace. So at the moment, only REST template and web client supports auto-instrumentation. It also means context propagation, but we used REST template, right? So we use REST template. Why didn't we see it? About that, we have to check the Spring Web instrumentation auto configuration. So in here, you see here, we auto configured a REST template bin post processor. As you know, the bin post processors only work when we have a REST template bin. So whenever we have a bin of type REST template, it will post process. So it will update our REST template with the OpenTelemetry properties. So basically, here, because we are using the REST template built directly from the builder without create a bin of REST template, so that's why the bin post processor cannot work. So in order to make it work, we have to create a bin of REST template. Okay, let's put it in the application. So here, so we are going to create a REST template as a bin here, right? And back to client, we just need to auto-wire it. Okay, so then requirement constructors. So auto-wire the REST template from the bin in here. I will extract the path variable here, the value from bin factory annotation value, right? So to get the value from the YAML configuration files. So this, we will replace this one by the base URL here, and we're going to update it in our configuration file. So we have order service base URLs is now localhost 8080, and that's why. So this is now our localhost 8080, right? Then we REST template. Okay, let's try to refresh application and send some requests. See, 1, 2, okay. Then back to our tempo, trace, invoice service. Okay, this coming. Okay, so it's good now. So now we can see we have the propagation from our invoice service to order service. So we have invoice service and call to order service. So wait for the response back to the invoice service and return it back to client, right, the browser. Okay, that's good. Okay, the next thing we're going to check is the log. Let's go to our documentation again. So for logging, we have to provide the OpenTelemetry appender as we did in the Spring Boot 3 Observability Series. And if you remembered, after we provide the logback stop string.xml, then we have to register the OpenTelemetry with this appender. So let's add the logback. Here's your file, logback spring.xml. So we'd like to use the default login pattern from Spring Boot. So instead of create a new console appender here, we use the default Spring Boot one and only add the new appenders, the OpenTelemetry appender here, and that's it. So now we send the console to log as normal, and another thing to our OpenTelemetry appender. So where do we register our OpenTelemetry with this appender? Now you may want interested into this OpenTelemetry appender auto configuration. So as you can see here, so when our applications started, so the application ready events is triggered, right? So then we also triggered our OpenTelemetry appender install our OpenTelemetry object. So that's why everything is on set. Then let's try to run and see our log. Okay, let's send the request. Okay, we have and let's take a look at our log key. So job. Okay, here we see we going to have the invoice log, right? Close this. Okay, so invoice logs, internal server error. So when we call order service to get the order number 3, we get the internal server error in the log, and the other log here. We also see the chase ID and the span ID of our log. That's good. Then let's check to our template and search for invoice service, right? Invoice service, and we have an error. We send the ordered invoice ID and we send to the orders. Then I would like to see the log from the invoice service. Then we see the log from invoice service. So the internal server error. And if we would like to see the log from order service, I would like to see the log from order service. It's an invalid ID, illegal argument exception. Okay, that's it for the video. We will end this video here. Thank you so much for taking your time watching this video and this series. Hope you can learn something new here, and see you next video when we enable native comply and build GraalVM native image for this service. Happy coding!